Hello, good morning. My name is David Ibinaye. I'm currently studying Masters in Cybersecurity at National College of Ireland. This video was created as a coursework requirement for Secure Programming for Application Development module. Here I will talk about the tools used in static analysis of the application code, the manual review done on the application code, the testing technique used and why it was used, what happens when security principles are ignored in programming, and the importance of security testing. In the static analysis of the program, I used two IntelliJ plugins. IntelliJ is an IDE for Java programs. One of the plugins used was FindBugs. FindBugs is an open source free program used to search for Java code bugs by static analysis. It ranks the vulnerabilities found in 4 stages: scary, distressing, disturbing, and of interest. This provides the developer with an indication of its possible impact or severity. The second plugin used is called SonarLint. SonarLint is an IDE plugin used to identify issues of quality and resolve them while writing the software. Using SonarLint, you get to take advantage of thousands of regulations that identify common errors, faulty bugs, and recognize vulnerabilities. SonarLint identifies where the issues is and recommends how they should be solved. Here is a screenshot of the vulnerabilities listed below in the IDE by SonarLint. On the first try of the automated analysis, it found 23 vulnerabilities, which was later addressed. On the basis of manual code review, here is a list of vulnerabilities found in the application code using a predefined template. This is just the first 2 pages of the application code vulnerabilities found. There are about 5 or 6 pages in total. Because of time constraints, I will always be discussing one of the Java files called db.java. Also, in line 34, a CWE 396 vulnerability was found, which is code for declaration of catch for generate exception. Catching overly broad exception promotes complex error handling code that is more likely to contain security vulnerabilities. The proposed solution was to explicitly state the multiple catch block. Class not found exception and SQL exception must be used as seen in lines 73 and 76. The testing technique used was code-based testing technique. In code-based testing technique, the programmer is allowed and is given the source code of the application for in-depth review and vulnerability check. It may be proven as a slow technique, but if implemented in the early stages of the software development lifecycle, it would save cost of debugging at the later stages of development, and also supporting software is not needed in this testing technique. On the grounds of what happens if the security principles are ignored, the security tests are designed to define the system risk and evaluate its vulnerabilities, so the system isn't being exploited. It also helps to detect all potential device security risk and allows the developer to resolve these issues through coding. If and when a programmer chooses not to apply these security testing principles, it could leave the application code full of bugs and vulnerable to attacks. The importance of security testing. The main aim of security testing for application is to detect and fix vulnerabilities. Staying on top of recent security vulnerabilities can keep you one step ahead of hackers, constantly validating the security of your application code. It also saves the programmer time and cost of having to create patches for the flaws in the application code after the public release. Thank you for your time.